Well, how's everybody doing tonight? Get some practice in this week,
I'm
hopefully.
doing good. And yes, I got practice in with you.
Good. And I know Joseph did too, so that's good. We'll wait a couple more minutes. Hopefully some more people will show up. I guess while we're waiting, did you guys see the study guides, practice tests on Canvas for this class? We're going to be going over PowerPoint that we didn't get to last week, and then some of those study guides.
No, I did not. I mean, I saw them, but I haven't gone over them.
Okay, cool. All right. Do you guys have a bunch of other finals this week too, or next week coming up?
I do, yeah.
Yeah, maritime environment, boat handling, this class, and I think that's it.
Are they all written exams, or is like boat handling practical skills you have to do, like assessments?
It's a 50-50.
50-50.
There is a written test, but there's also the practical portion.
Cool. That sounds fun.
I mean,
Joseph,
practical.
are you talking about night ops? Is that like the practical portion?
No, night ops is completely separate. There's for our final exam, there's supposed to be a written test and also there's supposed to be a practical portion.
Oh, like we're going to be in the boats? Because I know we are going
Yeah.
to be on the boats that day, but I don't know if that's like a actual test portion.
I think she's going to give us the multiple choice written test first, and then from there we'll migrate over to the boats.
Oh, yeah, I thought the boat portion was not like tested. It's just like another lesson.
1 second.
Anyways, I'll figure. But yes, to answer your question, Captain Bree, we have other finals.
I remember those final weeks in college, and it was just like horrible. I hated it. Always like right before the holidays. It just happens at the wrong time. All right. Well, is Lucy with you, Joseph? Do we have 3 people at least?
Lucy is actually on her way home from work right now.
Okay.
They ran a little today, so she'll be here shortly.
Okay. Well, I think we're gonna get started. Even though it's just 2 of you guys. It's almost 15 minutes in the class. All right, well, we're gonna do the PowerPoint, the rules, ARPA, and errors PowerPoint that we didn't get to last week. So I know it's a little bit of catch up, but I think our review was pretty needed last week. So I'm glad we did that, and I'm hoping to get some review in tonight as well. But I just need to go through this PowerPoint too. So that is our plan, and I know you both that are on right now had contacted me and worked with me, and I'd be happy to do that again sometime this week if you want. The final exams are going to be available tomorrow. So starting tomorrow until I think next Wednesday. I think I have it Wednesday to Wednesday. So if you want to look at them and practice them, I'd suggest doing that. Yeah, I should just do that. You could even submit it early if you want. For attendance wise, we will have to be checking in here next week as well. But next week, all I have is the 3 finals. So I think this class is like 4 hours, but sometimes our plots take a long time. So I don't know, depending on you guys, it might take 4 hours to do all 3, or you'd be out of here in 2 hours. Depends on you guys, but I'll go over that more later. That's really all I have for announcements. Let me share the Canvas real quick. I think it's in PowerPoints. So week 7 is review. When I do the week 7 study guide, these are the study guides I suggest. We have practice test for the single plots. There's 3 of them, same format that it'll be for the exams. Practice test for multi, there's 3 of them, again, same format. And then some practice test theory questions. So I'm sure you've taken, well, I'm not sure, but you may have taken like Coast Guard format exams in your other maritime classes, where it's like multiple choice questions. They're all from like the Coast Guard bank. Typically that's what instructors use, just so you can get used to this Coast Guard questions if you're going to be taking any Coast Guard tests. So the practice test and the final are all that format. So there's a practice test for you there, but then to really catch up on our theory, I have 3 of those homework things. I think we did them, what was it? We did it like, I think it was like week 2 homework or something. Yeah, it was week 2 homework. So just kind of a fill in the blank. The answers are there for you, so you could just look at the answers if you want. But they are great review for the theory stuff. So check out Canvas. Yeah, that's Canvas. Let's dive into a new topic. Okay. Any questions about what's going on with class? You guys doing okay?
So far, so good.
Okay, cool. All right. So we're going to catch up on rules, ARPA, and our errors and limitations. And then we're going to get to practicing. Hopefully lots of practice. So I think you guys had rules in maybe boat handling class. So this hopefully will be a review for you. But we're going to go over rules of the road. So why do we have rules in the first place? It's all about safety. So if you're confused on which rule goes who has the right of way in such situation, kind of go back to like, what would be safer here? Like when we have our hierarchy, the rule 18, not under command, ram, et cetera, the whole hierarchy. It all goes by safety. Who is safe, can safely avoid the other person. So we always go back to that. What would be safe in this situation? Everyone must follow the rules everywhere, no matter if you're recreational boaters, you're, on a jet ski, or you're on a container ship. Everyone has to follow the rules. Does everybody know the rules? No. But is everyone supposed to follow the rules? Yes. And this goes back to, or pretty much leads into, the Admiralty courts. If something were to happen, the courts go back to the rules of the road. Who had the right of way? Who's more at fault than the other person, and they figure that out by rules of the road, not just people's personalities, which is what it can be a lot out there. Anyways, okay, So when we focus on radar and rules of the road, we're not going to dive into all the rules. We're just going to dive into a handful. We have 2 through 8, and then we have rule 19. So hold on, let me go to this page. Hopefully everyone has a rules of the road book, but I always like to look at that beginning table of contents, and you have your part A, B, C, and D. So in your part, I'm gonna find it right here. In your part B, your steering and sailing rules, that's where we get a lot of our rules, right? Our rules, what is it? 4 through 19. So pretty much all the rules that we're talking about are in part B for radar. But we have 3 different categories within part B. We have in any conditions, we have in sight of one another, and then we have not in sight of one another. So basically restricted visibility, you can visually see them, or any and all conditions. So we really want to make sure we know which rules belong in which category, which we are going to be diving into, but let me go back. So yeah, these are the rules we're going to talk about, and let's dive into them. Factors that lead to collisions, inefficient watch keeping, and that's, you know, serious watch keeping, not just, I guess what I'm saying is a lot of people don't take it very seriously. Excess speed, lack of assessment of the situation. You always want to have that situational awareness. Early and positive action, passing or overtaking too close. Again, that too close is very, I guess, personal. Too close for me might not be too close for you, or too close for you might be fine for me. So it's very subjective, I guess was the word I was looking for. Failure to observe the traffic separation schemes. Again, these traffic separation schemes, I'm sure you've heard, are not marked anywhere out on the water, right? There's no buoys to say stay within these traffic lanes. It's only on the chart. So if you don't have a chart on board, or you don't have electronic plotter, you might not even know you're in a traffic lane. Therefore, you're not observing it. So you always want to know where these things are. Incorrect lights and signals. Yeah, that makes sense. Mechanical failure or negligent maneuvering. And that negligent maneuvering goes back to our, if we are giveaway vessel, we are not crossing in front, we're not, you know, pedal to the metal and just charging in front of someone that we have to give way to. So kind of that use good seamanship, which I think is going to be our first rule that we're going to talk about. Okay, first we're going to say to avoid collision, take early action, take substantial action, check your action, and then reassess. And if you need more time, stop if necessary. Stopping underway is hard. So they call it bare steerage, which I think we're gonna dive into a little bit as well, but sound proper signals. Okay, let's dive into it. This is a review for you guys, I think, but we have the international and inland rules, right? Our inland rules are everything within that Colregs line. Anything ocean side of the Colregs line is the international rules. So if we're in Newport, anything inside the jetty is inland, anything outside is international. If you're in a place like Puget Sound or something, I guess I worked a lot up in Puget Sound, it's all international because Canada is part of Puget Sound, and just it's all international. So you always want to know where it is. It sometimes doesn't make sense, if you will, but a lot of times it does. So, okay. We're going to dive into each of these. So I am skipping that. Okay, so rule 2 is basically be smart. Don't be a dummy out there. Use good seamanship, use good judgment, and basically act like people think. Be predictable is pretty much what it is. Follow ordinary practices in your area. Just use good seamanship and be predictable. It's rule 2. Rule 5 is the lookout rule. You always need a lookout. No matter what size boat you're on, wherever you are, you need a lookout. Okay, I was like, geez Louise. And that means hearing and seeing. So your lookout can't be below, and your lookout can't have, earbuds in or whatever. You want to have all available means, meaning if you have a radar, you want your lookout to understand all available means, meaning what are these blips coming up on the radar? So everyone needs a lookout. And you need to be able to report it quickly. So I don't think it really has much to do with recreational boating, but if your lookout is up on the bow and you're on a long container ship or something, and it takes 10 minutes for him to get from the bow up to the bridge to report something to you, that's not a good lookout. They need to be able to report it quickly. Typically by radio or sound-powered phone if you're in a situation like that, but okay. It is the most important job on the vessel, says the Supreme Court, which is pretty important. Okay. Maintained at all times. So at all times you are underway. You have to have a lookout. So even if you are single-handedly sailing across the ocean and you want to sleep or take a nap, technically you're supposed to have a lookout at all times. That lookout has to be trained and experienced, meaning your lookout can't be your 2-year-old. They need to, know what they're looking out for and how to report it to you. Also properly stationed, not, down in the galley making cocktails. Your lookout needs to be properly stationed. Alert and vigilant. So all makes sense, right? We need a proper lookout. All available means, meaning using sight, hearing, and your instruments. So your radars, your AIS, any sort of thing that helps with navigation and collision avoidance. This one says use relative bearings to report. That's not necessarily, it all depends on your team, right? If your lookout knows relative bearings and you understand relative bearings, great, use that. Use whatever is understanding between everybody there. So you don't want to use like relative point system if you're the only one that knows that. If your lookout only knows like clock system, they're at 2 o'clock or 9 o'clock or something, use the clock system. It might not be proper or, the way the book says, but you just want that positive flow of communication. So find what works for your crew on board and use that. Again, you could train someone in using different terms if you want to, but using terms other people don't know just lead to miscommunication and failures in the chain, and can lead to bad things happening. So I always think positive communication is incredibly important on board, because you are trusting other people's to do their jobs and communicate to you. So that communication is incredibly important. Okay, off my soapbox. Rule 6 is safe speed. So for all vessels, visibility, right? If it's foggy, if it's clear, maybe you're comfortable going faster. Just like if it's excuse me, foggy when you're driving, excuse me, hold on. Sorry. Just like if it's foggy when you're driving down the road, you might slow down a little bit because you can't anticipate someone coming around the corner or changing lanes in front of you as quickly as you can if it's clear visibility. Maneuverability. So maybe safe speed for a, quick power boat might be a lot faster than safe speed for a heavier vessel, because they can stop or turn or maneuver way quicker than, say, a deep draft vessel. So that maneuverability is different for every vessel, and that has a lot to do with safe speed. Traffic density, makes sense. The environment, that's our wind and waves. And then our background lighting. So maneuvering, navigating at night. I think you guys said you guys were doing night ops, right? It can be incredibly disorienting because lights are very hard to tell distances. It might have a very close light to you, but it's dim. It doesn't have that looms or that brightness. Or you have a light far away that's like a super bright LED light, and it's very hard to tell what's closer, what's not. If you're just looking at these lights, it can be very disorienting. So you might want to slow down to give yourself time to have that situational awareness. And draft, which really has to do with maneuverability. So that's kind of combined in there. And I guess draft as well if you are approaching coastal waters and you want to slow down to make sure your feather number doesn't jump and you run aground. But yeah, okay. Safe speed with radar. Now we have, 5 more factors in if you have a radar that you have to take into account. I guess some of them are the same, but one are limitations. So kind of what is that radar's maximum range and what is that radar's minimum range? And how is that going to affect our speed? How much are we depending on that radar? And if we are, what are the limitations of that radar? And we're going to get into some of those errors and limitations more later tonight. Traffic density, again, your range scale. So if you're on a 3-mile scale, because that's what it takes to be maneuvering this river, you're really not, long distance planning up ahead for 6 or 12 miles out. So it all depends on what range scale you're on to help with that safe speed. Sea state, with those choppier seas, you have less radar accuracy, I guess I would say, because you might have that sea clutter on to smooth out the chop that you're receiving on your radar. And then you might, be wiping out essentially, a small boat or something like that. So that sea state can affect, that return that you're getting on your radar and how good what you're seeing is. And then just the presence of small vessels. Again, small vessels are much harder to pick up on radar. So if you're only depending on your radar for collision avoidance, I would definitely slow down because you might not see these small vessels until they are very close to you. Any questions on safe speed? Okay, excuse me. It's like as soon as I start talking, my throat gets dry. Every class. Okay, rule 7, risk of collision. So we have been doing this with our paper plots, right? Does risk of collision exist? If it does, who's the giveaway? Who's the stand on? What do we have to do? So risk of collision, CBDR. Does anyone know what CBDR stands for? You can put it up in the comments or the chat. No. Let's say we got one. Nope, not collision. You want to avoid collision.
I have no idea. I've never even heard of CBDR.
Oh, okay.
I can't remember.
Okay. Constant bearing, decreasing range. I guess some instructors go crazy with the CBDR, constant bearing, decreasing range. If something is on a constant bearing, that means, and they're decreasing range, risk of collision is imminent. If their bearing is changing to the forward side of you, they're going to cross ahead of you. If their bearing is changing aft, they're going to cross behind you. So a very quick way to figure out if risk of collision practically exists, I always, if I see a target or blip on the radar and I don't even know if it's a vessel or not, I just put an EBL line there and then come back a few minutes later. If the blip is still on that EBL, it's constant bearing. If the blip has moved forward or aft of that EBL, then their risk of collision doesn't exist, and I don't need to change course or worry about him too much. I mean, I want to monitor him to make sure he doesn't do anything crazy, but risk of collision isn't there. So the rules of the road always comes down to, does risk of collision exist? If it does, this is how you should act. So, and how to determine if risk of collision exists is that constant bearing, decreasing range. That's that relative motion coming straight at you, right? Okay. Oh, there we go. Constant bearing, decreasing range. Okay. Okay, so here is a little picture. Wait, we'll go back here. So this guy is bearing 045, but he's headed in a different direction than us, right? Well, a little bit later, he's on the same bearing, but much closer. A little bit later, he's on the same bearing, but much closer. And then we get a collision. So that's kind of a illustration of that constant bearing, decreasing range. With rules of the road, if you are in question, if you are in doubt, is technically how the rules of the road likes to phrase it. If you are in doubt if risk of collision exists, assume it does. So you're like, I don't know if risk of collision exists. Hopefully it doesn't. I'll just keep, maintaining course and speed. Assume that it does, and then figure out, are you the stand on or give way? What action should you take? Should you maintain course and speed if you're stand on, or should you give way? So assume risk of collision exists if you're in doubt. Look out the window, always a great tip. A lot of times with radar, I know I kind of laughed at that, but a lot of times with radars on board or electronic plotters on board, people can get focused on maneuvering or ship handling by the electronics. So, and then you can get flustered by looking at things on all of these little screens. So it's always good to just take a breather, look out the window, see what's going on, and then decide what you're going to do, because it's very easy to get hyper focused on those electronics. They're great tools, but you always want to look out the window as well. Okay. We have our little cycle here. If risk of collision exists, determine responsibility. So we want to determine, are we give way or we stand on? And then what are we going to do about it? And we're going to do it in ample time. So we don't have to maneuver when they're 12 miles away, but we will have that MX somewhere in ample time that's not too close. And then we want to check the results. Did what we think was happening? Is he following along my new relative motion line? Is that correctly happening? So see if it's working. If the other vessel changed course or speed, maybe we need to do something else. Maybe our calculations were wrong. We don't want to just set it to a new course and be like, all right, I did my paper plot, I'm good to go. We want to always keep checking. So I'm sure that's gone on one of your classes. Okay. I'm going to do this whole thing. Okay, so in this situation, I guess, oops, I'll go back to this one. So this situation, this is the giveaway vessel, and this is the stand-on vessel. So we are the stand-on vessel, right? Because we are to starboard of this vessel. They see our red light, we see their green light, we are stand-on. So we maintain course and speed. So if you're in zone 1, that is before any action is okay. So kind of before this risk of collision exists. And then we get to a point where we're like, yeah, risk of collision exists, but I'm not quite going to do anything about it yet. We're still pretty far away. Then we get to a point that says, I don't think this other guy is changing course or speed. I don't know if he's going to avoid me or not. I might sound the horn. And in this area, I may, the rules have this thing where they have may and must. May and must. It's super annoying, but that's the Coast Guard for you. You may turn to starboard. So it is okay for you to turn to starboard, but you cannot turn to port. So if you are in doubt, you may turn to starboard. If you get to the, what do they call it? If you guys have taken rules, you know what this is. God dang it. What is it called? It's, I want to look it up, but I can't think of it. It's off the top of my head.
Point of no return. No, I'm kidding.
No, it's a weird word. Oh God, what is it? Okay, I'm gonna think about it. I'll get it back to you guys. You get to zone 4, we'll just call it zone 4. You must take action. So if you're in zone 3, you may take action. If you're in zone 4, you must take action. If collision is imminent, maybe that's the word, I'm not sure. You must take action. So therefore, it can't be 100% the giveaway vessel's fault. It is partially both vessels' faults, because when you get to that point, both vessels must do something where if risk of collision is imminent. So it shouldn't, it says it's okay to turn this way. If you must turn to port, you can. But both vessels have to do something when it gets to that risk of collision is imminent point, which I'm going to find the proper word for. But does that make sense? Where this is kind of the may zone and this is the must for the stand-on vessel. Have you guys heard of that before? Maybe, maybe not. Okay. Okay, so who is the burden vessel? Who has the rights, and what are those responsibilities? So stand-on vessel, maintain course and speed. And I would also add here, monitor the giveaway vessel. Make sure they're doing what they're supposed to be doing. But your duties or responsibilities are to maintain course and speed, be predictable, right? Giveaway, if you're the giveaway vessel, you want to take early and substantial action. So this definitely goes into substantial action. A lot of times, can they see your vectors change on your radar screen? If you only change course a little bit, you might not even notice that vector change. So you want to make it substantial, make it predictable. Oh, this guy is turning to starboard. Yes, I can see his vectors changing. That is a substantial action. Even if you only have to change course like 10, 15 degrees to get that 2-mile CPA that you want to change course significantly, and then to just make it apparent, and then maybe you can adjust back a little bit. But you want to make that substantial action to show the other vessels that, yes, you understand you are the giveaway vessel, you are going to be giving way, and this is my plan. So you want to be that predictable. Again, distances on what that early action varies. Early may be way too close for comfort for me, but not for you. So again, that's very interpreted different ways. At night, you want to see the boat's lights change. So how I was talking about the vectors changing, that's if you're using a radar. But looking out the window, you want to change course so significantly that the other vessel can see your lights change from red to green, whatever it is. So you want it to be apparent what you're doing. And at night, it's hard to see the aspect of your vessel, so you're dependent on those lights. Any questions on that? On stand-on or giveaway? I think you guys have gone over that in other classes. I hope so. Okay. Excuse me. Okay, so if you are in sight of one another, so this is in our part B, if you are in sight, meaning you could see the other vessel, then you have 3 possible situations that can exist. Well, I guess technically 4. The first one I would say is no risk of collision exists. So you're inside of one another, but no risk of collision exists. Second one, you're inside of one another and a meeting situation exists, or you're inside of one another, a crossing, or you're inside and an overtaking. So you want to figure out which situation you're in So then you could figure out who is give way, who is stand on. Again, if you are in question of am I stand on or give way, just assume that you're give way and take action accordingly. So when we, and this, I like this one in relation to our radar or our paper plotting. So if we are headed due north, anybody who is being plotted in this sector is going to be our give way in a crossing situation. Anyone that is plotted in this sector is going to be a stand on, or we will be stand on. They will be give way in a crossing situation. If they are dead ahead of us, it's a median situation. Or if they are anywhere, do you guys know what angle this is? In degrees?
Is it 100?
Which one?
Because 90 would be the like 270 or 90.
Yeah.
Would it be 100? I'm just guessing.
No.
5 degrees.
Okay, it's
Like
22 and a half points abaft the beam.
Oh, I meant purple all the way down. Like
yeah,
this is
so that would be
122.
112.5. Right? 90 plus 22. 112.
Yeah.
And then this is 135 degrees. I know that. So these all have to do with your, let me go back to, sorry. I'm skipping a lot here. Okay, never mind. I don't have that slide. Which is weird that I don't. It goes back to the, you know what? Stop share. I'm gonna put that slide in. Sorry. To your nav lights.
Oh. Is that like a blind spot, that section? The 22 degrees to starboard and to port?
No.
Why that's sliced off like that? No.
Why it's cut off like
like not
it,
I don't know why it's even significant.
Hold on 1 second. Let me make this slide will make things make a little more sense. Oh shoot, that's PFD. Where's my slide? Okay. Okay, zoom and share. Okay, so these are your navigation lights, right? We have our green light on our starboard side, and its angle from the bow is 112.5 degrees. Green, or the red light, 125 to the 112 the other way. And your mast light, the white light, is 225 degrees. So your mast light and your running lights kind of follow the same arc, if you will. And then your stern light is the 135 split in half. So you have that 67.5 on each side, but that's your stern light. So if we go back to this, are you in a crossing, meeting, overtaking situation? It has a lot to do with the lights, right? The lights that you see, the lights that you are showing other people, right? If they are seeing your red light and only your red light, maybe your red light and your mask light, if you have both, then that is a crossing situation. If they see both your red and green lights, then that's a median situation. If they see only a white light, meaning only your stern light, then they are somewhere here in the overtaking situation. So we could look at it with the colors, right? If they are somewhere only seeing a white light, then that's overtaking. If they are somewhere in this sector, they're seeing a masked and a red, that means they are giveaway. It's a crossing situation. On this side, they're stand on if they're seeing a masked and a green light only. If they're seeing both red and green, then that's a median situation. If they're dead ahead. Does that make sense? Hopefully you guys have gone over this in other classes. Okay. So again, another drawing of what situation we're looking at. Okay, so if you're in a overtaking situation, you have this 135 degrees, it's okay for you to go to the starboard or the port side. The rules don't say which one you need to, but you have to, stay clear of the stand-on vessel. In a median situation, both vessels are giveaway. There is no stand-on vessel. And both vessels should alter course to starboard and pass port to port. So passing port to port is the most common way of passing. And it's kind of also the most anticipated way. So even if it might be easier for both vessels to pass starboard to starboard, you want to have that clear communication, whether it's VHF radio, whatever it is, you want to make it clear that you're passing starboard to starboard if you guys are doing that. I would say it's not common. Most vessels will assume that you guys are going to pass port to port. So, I mean, I'm not saying that I've never passed starboard to starboard, but you want to make it clear, especially if you're navigating an area that doesn't have strong English speakers. Okay. And then we have our crossing situations, right? We have our stand on and our giveaway for our crossing. So if the vessel is to starboard of you, you always want to turn to starboard and pass port to port, right? Essentially, you're turning to starboard and passing port to port, and letting this guy pass in front of you. So you'd never want to pass in front of the giveaway vessel. Same with here, they're going to turn to starboard, pass port to port. Now, if I'm the stand-on vessel, say in this bottom situation, and I am unsure if a risk of collision exists, right? And I might just assume I'm the giveaway vessel, or I'm the, giveaway vessel, and my action would be turning to starboard, that wouldn't quite put me as in a risky situation than if I turned to port, right? If this stand-on vessel turned to port, that would make the situation a whole lot worse. If they turn to starboard, and you guys are both making way, you kind of have more time to be like, what the heck's going on? What is this guy doing? And it's not as, two vessels coming at each other. It's two vessels going with each other. So again, you want to maintain your responsibility of just maintaining course and speed. But if you're in that situation, you're in doubt, blah, 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 turning to starboard is always the safer maneuver. There's really no maneuver to turn to port. You don't want to turn to port. Okay. We did this slide. Okay. Any questions on those approaching situations before we move on? Okay. Rule 19 is our visibility rule. So this is in restricted visibility. So before, our safe speed, our good seamanship rules, those were any visibility or in any condition. Restricted, not restricted, clear, whatever it is, any condition. Then we got to our, meeting, overtaking, etc., meeting, overtaking, crossing situations. Those only occur when they're in sight of one another, when you can visually see the other vessel with your eyes. So then we move to Rule 19, which talks about restricted visibility. So your fog, your rain, anything that restricts your visibility, even if you're near an area of restricted visibility, that whole crossing situation goes out the window. There is no crossing situation. There is no overtaking, no meeting situation. Those don't exist. Those only exist when you are in sight of one another. So if you are not in sight of one another, in restricted visibility, these are our rules. Does that make sense? Gosh, I'm gonna have to get a cough drop. Okay. So diving into restricted visibility, our conduct, we want to maintain a good lookout. We want to sound the proper signals. We want to slow to bear steerage if we have to, and keep our nav lights on. We'll go into the bear steerage in a minute. What is the sound signal for a vessel underway making way? Okay, we haven't done sound signals in any of our classes yet.
Ask that
We
again.
have, but
You said
that
make
one seems to slip.
Okay, so it's going to be, do you know what frequency, like how often do you sound a sound signal?
Depends on the weather conditions, really.
In restricted visibility.
Then every 2 minutes.
Yeah, every 2 minutes.
2 minutes too.
Every 2 minutes. So for a vessel making way, underway, your standard, most, I would say 75% of the time, vessel is going to be your 2 prolonged.
Oh.
So that's
2 prolonged.
5 to 7 or 4 to 6 seconds. So basically 5 seconds, right? 2 5-second blasts. That is your sound signal. Okay. Rule 19 only implies when you're not in sight of one another, right? If you're not in sight. Rule 1 through 10 still apply. So that's your behave well, good seamanship, safe speed. I don't know what the other ones are. Let's look. Narrow channels, does risk of collision exist? Take action to avoid collision. Have proper lookout. Those are our rules that always apply. But what doesn't apply is this crossing meeting situation thing. So has anybody been out there in restricted visibility? Has anybody been out on the water?
Yeah.
Okay. It can be very disorienting, right? Just like navigating at night can be disorienting. When you can't see anything, it's very hard. When we bring it back to radar, it can even be more challenging. If we are in, the rain squall or something, right? Rain is a reflector of our electronic, whatever, our radar signals that we're sending out get reflected back by rain or water. So we can get these giant blind spots and be totally surrounded by blind spots if we are in a very heavy rainstorm, meaning we can't depend on our radar, we can't see anything out the window, and it can be very anxiety producing. So we want to know how to behave and depend on our Rule 19 in a situation like restricted visibility. Here's our fog signals. Okay, underway, oh, I had it wrong. Underway making way is 1 long, underway not making way is 2 long. My bad, I had it wrong. All of your, not as maneuverable vessels have your 1 long, 2 short. And then if you're at anchor, you add in the bells. Okay. Rule 19 continued. Take precautions, proceed at a safe speed. Yes, we always want to proceed at a safe speed. Power-driven vessels should have their engines ready for immediate maneuver. So that's kind of a weird phrase, right? Like, when are you not ready for immediate maneuvering? But large, tankers, container ships, those such, don't have their engines ready for immediate maneuver. It takes a long time for a vessel to go from sea speed down to maneuvering speed. They have to do this load down is what they call it. And they have to load the engine slowly down, that you can't just go exactly to stop. There might not even be engineers in the engine room. So anytime that you are approaching land or in restricted visibilities, you want to have your engineers down in the engine room and have the engines ready for immediate maneuvering. Put that in a recreational boating, pretty much you're always in immediate maneuverability, right? You can change your speed. You don't have to go down to the engine room. But just to keep that in mind when you are navigating around large vessels, they can't just stop, and then it takes them a while to stop because they're heavy, right? But it might take them an hour to go from their 112 RPMs to 50 RPMs, which would only be half the speed. So it takes them a while to slow those big giant engines down. So that's what that means. Okay. So when a vessel is detected in restricted visibility, you kind of have these 2 possible ways. You detect the vessel by radar alone, or you detect the vessel by hearing a fog signal. So if you can't see anything, right? You can't see anything, but you've detected a vessel. How have you detected that vessel? By radar alone, or by hearing that fog signal forward of the beam. We're going to look at those individually. If we detect a vessel by radar alone, first we need to determine, does risk of collision exist? Is a close quarter situation developing? If it is, we need to take avoiding action. In this point, we don't have that who's give way, who's stand on guide to tell us what is the proper avoiding action to take. So we have this Rule 19. If that vessel is forward of the beam, right, we do not want to turn port. So we want to turn to starboard. I wish it just said turn to starboard. If the vessel is forward of the beam, we do not want to turn to port. I feel like it's a double negative. But again, if the vessel is forward of the beam, we want to turn to starboard. We don't know if it's a meeting situation, a crossing situation, whatever it is. If the vessel is somehow forward of the beam, only detected by radar, we turn to starboard. If the vessel is abaft the beam, meaning behind us, we can take avoiding action by turning, but we don't want to turn toward the vessel. So if the vessel is on our starboard quarter, our starboard behind our beam on the starboard side, we want to turn to port. We don't want to turn to starboard, kind of maybe in front of him, maybe not. We don't know exactly what he's doing. But because we've only detected him by radar, we don't want to turn towards a vessel that's abaft the beam. If they're forward of the beam, we don't want to turn to port, we turn to starboard. If a vessel is detected by a fog signal, by hearing alone, we want to determine if risk of collision exists. Now that can be very hard, right? Because it's very hard to get that constant bearing on hearing a fog signal every 2 minutes. It's challenging. So this situation would be very hard to figure out if risk of collision exists. If in doubt, risk of collision exists, assume that it does. That is one of our 1 through 10 rules that apply in any condition. If in doubt, risk of collision exists, assume that it does. So we're hearing this fog signal. We can't see it on radar. We don't know where it is. It's apparently forward of the beam. We don't know if risk of collision exists. We're going to assume that it does. And this is where we reduce our speed to bear steerage, to slow things down so you can take it all in and figure out what's happening. So that bear steerage doesn't mean you go all stops, because then you typically lose control of your vessel. You always want to maintain control of your vessel. So this is kind of, I know a lot of people have different type of engines and things these days, but this kind of goes back to the standard propeller rudder situation. So if you don't have any water coming over your rudder isn't doing anything. If you're dead in the water, your rudder can't help you steer, right? You need water passing over your rudder to have steerage, to maintain your heading. And that's kind of that, I think I was talking to Joseph or Sabrina about it, that like hove to situation where you're maintaining where you are, but you're always managing your heading. You're always in control of the vessel, that you're not just like, whoo, we'll just see what happens. And then you'll tend to go downwind. Your bow will tend to turn downwind and you'll start drifting downwind. So you always typically want to keep your bow into the wind and just maintain your heading, but without, making way, without going forward and getting closer to this vessel that you may or may not have this risk of collision. So that's what bear steerage is. It's just enough speed. So you might be like bump ahead, back to all stop, bump ahead, back to all stop, just to keep control of your heading, meaning having water come over your rudder. If you have like a jet propulsion or Z drive or, all sorts of other kind of propulsions these days, bear steerage is just whatever you can keep your heading with. So, okay.
Can I ask you a question, Captain Bree?
Yes.
And I think that was me, maybe it was Joseph too, but the hove too, because I remember I was like, how do you spell that? So I think that was with me.
Okay.
I'm looking on my old notes for sound signals from, I don't know, one of the classes with Captain Perlow. Not old, but like this semester.
Yeah.
And then I saw channel 8.1. I have my notes say foghorn. Do you know what that means? Like, can you do a foghorn on channel 8.1?
pretty sure that means that Newport, that light or the one of the day markers on the Newport jetty.
Oh.
If you like click the radio on channel 81, it will sound that fog signal.
I see.
Because that's not a typical radio frequency for, you know, LA traffic or
okay.
anything around here. So I'm assuming that, because
Okay.
I know you can do that with that beacon, but I don't know exactly what frequency it is.
Okay.
So if you are, you know, approaching Newport and you can't see anything, you would be wanting that fog signal to go off so you can have something to be going towards.
I see. I think I remember that now. I wrote it quickly, so I didn't write what it was, but I do remember that now. Okay, thanks.
Yep. Okay, I just wanted to go back to this one to make sure I didn't skip over it, but I don't think I did. Okay, any questions on radar and rules of the road? I'm hoping you guys have had a little bit of rules of the road in the past, and this was just a review. But would you guys be ready to take a rules of the road quiz?
Sure.
It is a 10-question multiple choice quiz. Maybe here, let me share this for a second. There is the rules homework assignment. How much is this? So I might just give us like 10 minutes. Oh, that's not it. Give us like 10 minutes. You can kind of go over your notes or go over the homework review for rules or whatever it is, and then let's take the rules quiz. So it's 10 questions, multiple choice. It's on Canvas. So let's see. It is 7:15. Let's say I'll check back in at like 7:45. Maybe we'll get back to our PowerPoint at 8. If you guys are done with the quiz earlier than that, we can jump to it, but I don't want to rush you. So yeah, take a breather, look over your notes. Again, it's a quiz, so you can use your notes on the quiz. You know, the quiz is just kind of a practice thing for you guys. So let's do that. I'll be here if you need me, but yeah, I'll check back in at about 7:45. So take a breather, do what you need to do, and then go to the quiz on Canvas, the rules quiz we didn't get to. All right. All right, so that was a little bit of a rough quiz. That is an example of, you know, those Coast Guard questions, right? So try to practice the Coast Guard questions. You'll have a few of the rules questions, part of the radar theory questions. So on the final at least. And I did want to remind everyone that 70% of the grade won't even, of your guys' final grades, won't even be inputted until next week, where we have 20% for each of the finals. There's 3 parts of the final, and then another 10% for attendance. So keep that in mind if you're looking at your grades on Canvas. Okay, let's see. Let's move. Any questions about anything before we move on to the rest of the PowerPoint? Did you guys have enough of a break after the quiz? I don't know. Give me a thumbs up if you're ready to move on. Are we good? Okay. Okay, so we are wrapping up the rest of the theory stuff, and then we're going to get to practicing together again, the paper plotting. So we're going to talk about ARPA and what that is. Then we're going to talk a little bit about errors and limitations of the radar, and touch on maintenance and safety. So again, this all has to do with those theory questions. Okay. So ARPA is kind of this, I'm not a computer person, I don't know, computer software that can be installed with your radar, automatic radar plotting aid. That's what ARPA stands for, so that you don't have to do this paper plotting. So all that we've been practicing for the last 7 weeks has been a lot of this paper plotting, right? Well, if we have an ARPA, we don't even have to paper plot. I have never actually paper plotted underway on board a vessel because I've always had ARPA. So ARPA is super helpful because it just gives you a vector, and you could toggle back and forth between, you know, true and relative vectors, and try out CPAs, try out trial maneuvers. If I were to come 30 degrees, what kind of CPA would that give me? How would it affect all of the other targets around me? So I don't have to do all this paper plotting to see what one maneuver would do to affect all of the other targets. So with an ARPA, you can visually see it on the radar, and it's incredibly helpful. Has anyone used a ARPA radar before or seen it? No? Okay. This is kind of an example where they give you so much information. What's the range, the bearing? Okay, they don't have the heading or rate of turn. This is kind of a bad, course over ground, speed over ground, CPA, time of CPA. So it gives you kind of all this information, like the target's true course and speed, the CPA, the time of CPA. What it gives you this information that we've been getting from our paper plots, just digitally right there for you to process, and they even will give you a little you know, vector visual to look at as well. Now this one also has an AIS overlay, so it's giving you AIS information as well, but the ARPA does the plotting of just can acquire targets automatically. So you can say if anything gets within 6 miles of me, or 10 miles, whatever you want, it can acquire that target and start tracking it, and then it could even alarm if you have, you know, a CPA less than 2 miles or something like that. So the ARPAs are super useful. So hold on. Here. Go. My dog's being super annoying. Okay. What is the abbreviation for ARPA? Again, automatic radar plotting aid. It just aids you. So the radar itself has the same characteristics, right? Our, you know, radar waves are going out, bouncing off things and coming back. The ARPA has nothing to do with, you know, the fundamental process of the radar. It's just that plotting aid. So the ARPA is helping us plot, so we don't have to do paper plotting. but the radar itself is still, fully functioning own radar. The ARPA just helps us process that information. When it is working properly, it's a fantastic tool. I guess one thing that can be different with the ARPA, if one watchstander has it set to true vectors, and the other watchstander comes up and they want it set to relative vectors, and they assume it's on relative but it's on true, it's easy to make assumptions and misinterpret the ARPA information. So again, that qualified mariner with proper training is real important. Okay, what does the ARPA give us? It gives us true and relative motion for the radar presentation. So again, we have those, relative motion, our R to M on our paper plots, and our target to true course and speed. So we have those two vectors that we're getting from our paper plots. They will give it to us. It has automatic acquisition of targets plus manual acquisition. So you can manually say, hey, start following this target, or if this target gets at whatever distance, it will manually acquire it. So it's super helpful in that way. It gives you digital readouts of that, speed, range, bearing, CPA, TCPA, all that information that we're processing to see what risk of collision is. Let's see. I want to say it gives you the ability to display collision assessment information directly on the PPI. Okay, so all this information that we're getting is on the same screen that we're looking at. So we don't have to be on the chart table with our plotting sheets and then going back to the radar and then going back to our plotting sheets and then going back to the helm or anything. It's all right there on our PPI, which is our display screen. We also have the ability to perform trial maneuvers. I love this trial maneuver aspect of the radar. So you can say, hey, if I turn, you can even say, in 30 minutes, if I turn 30 degrees to starboard, what's going to happen? And it will change all of those vectors. Or if in 20 minutes, if I slow down to 5 knots, how will that affect everything? So it puts this big T on the bottom of the screen to let you know you're in trial mode, and those vectors aren't, the real life vectors. They're vectors if you were to do something. So, so it's a great way to, dial in what course you have to change to get your desired CPA. So it's a great tool. Automatic ground stabilization for navigation purposes. Okay, we're good on that. The ARPA does need history, right? Like on our paper plot, we use 6 minutes. It was here at one time, and then 6 minutes later, it was here. So we have that kind of that history. So let's do both of these. So the ARPA needs that history just like we do. And the more history the ARPA has, the better projection and the more accurate it will be. So kind of right when you first acquire it, and it, 3 minutes later, it gives you a little vector. That vector still might be changing a lot from one way to the other, depending on, how steady these pips are on your screen. So, so it needs this history. It needs the longer you are tracking it or have it acquired, the more information the ARPA has and the more accurate your information will be. So we also have that steady state tracking. So if the other vessel changes course or speed, or if you change course and change speed, all of that data that it's kind of averaging over the last 3 minutes is shifted, and it hasn't shifted all at one time. It's because it's averaging over the last 5 minutes, 3 minutes. So it takes a while, 3 minutes. I like to say 6 just because we do everything in 6 minutes, but it's technically 3, for it to give you good information again. So this is that, like, you know, trust the technology, but if things are changing, you know, bad input in equals bad input out. That, yeah, if anybody changes their vectors, then it takes a while for the ARPA to give you accurate information again. I feel like I explained that poorly, but I hope it makes sense. Okay. Any question on ARPA? Okay. Okay, now we get to our errors and limitations. So we're going to talk about multiple targets, indirect echoes, power lines, and then our limitations, our refractions. Okay, so multiple echo targets are these false targets on your radar screen. So if you have a very strong reflector, right, something that is a great radar reflector close to you, you can get this echo where the signal hits it and comes back and hits it and comes back and hits it and comes back, and you get these spaced out multiple echoes on the same bearing. Now, any of the things that come back always come back much, much weaker. So that's if you have this super reflective or super, I guess reflective, conductive, I'm losing the word, that reflects back, you can get these multiple echoes. Again, the further they get out, the weaker they are and the less the target will be displayed, but you can get this effect. So if you have on your radar screen, blips the same size, spaced out on the same bearing, you really want to double check that to say, are there a bunch of targets out there, or am I getting this echo, this reflection, whatever it is. Okay, you can also get indirect echoes. Same kind of thing of reflecting your radar signals one way or the other. So in this picture here, we're in the center of the screen. This is us. And then we have a buoy behind us. So here's this buoy with the radar reflector behind us, right? Well, we can get this indirect echo where some of the radar waves can bounce off of something on the vessel, a superstructure, a container, whatever, something close on the vessel, and then hit, you know, whatever object that is out there, in this case it's a buoy, and then come back, so that the receiver on the radar thinks that it's coming back from the other direction. So we can get this false echo right opposite bearing of what the true buoy is bearing. And then we can get kind of this ship's echo, which is kind of a back and forth, if you will, of the radar waves to whatever is reflecting off of it. So you get these two echoes that aren't really there. So you could be maneuvering and worried and stressing out over these echoes and you're looking out the window and you can't see them and we can't figure out what is going on, that is an example of an indirect echo. So it's just something to be aware of, right? You don't want to completely be like, oh, nothing's there, it's probably an indirect echo. But you might want to, change course a little bit one way or the other to see if those targets on your screen change or essentially go away. So you want to do something to see if that goes away. Or maybe you have, a giant container forward that you're like, it's probably most likely an indirect echo off of that. It's just something to keep in the back of your head. Okay. Then we have a power line effect. This one is really weird. So this is typically, where do we have power lines that you're going under? Inshore in, going to the Matson Dock in Long Beach, you have lots of power lines. Or if you're in a river or something, you might have, the Columbia River has lots of power lines going across it. Yeah. Anyways, you have power lines. The weird thing about power lines is that the target, even if you are turning for this target, the target remains on a steady bearing, even though you are turning. So whatever you're doing, that relative position isn't changing. And so you get this really weird power line effect. So the target remains on a steady bearing despite your course changes. So if you're traveling in an area of power lines, you want to be really monitoring those targets you get on the radar and then verifying, visually or using AIS or some other tool of what you're actually seeing. And with this power line effect, that change course one way or another to double check if this is a weird, indirect echo, multiple echo, what kind of, fictional target we're getting or fictional return we're getting on the radar changes. If you change heading one way or another, it might change. That's a very quick way to eliminate one of those things. But with the power line, it doesn't do that. It remains on a steady bearing despite your course changes. So you want to keep that in mind. Okay, now we're going to talk about kind of the limitations, if you will. And this talks about kind of our maximum range and our minimum range of the radar and how the energy from our radar antenna, the transmitter, can be affected by the atmosphere. So subrefraction, and I'm going to have multiple visuals of this, but subrefraction, which is a very weird term, is when that radar energy travels upwards. So even though it says subrefraction, that energy is traveling upwards. It's traveling towards the cold. So you have this warm water, maybe you're on the East Coast or the Gulf of Mexico or something, and then you have this super cold air. Your range of your radar is reduced significantly because that radar energy is just flowing out and then going up, and you're not seeing any of the targets past where your radar energy isn't going anymore. So when you have this warm water and cold air, we get less of a range, a possible radar range. So even though you can, say, oh, look, my radar is at 24 range, 24-mile range, it might not be picking anything up until things get within, in this case, 4 to 6 miles. When it gets closer, it will pick it up. But that energy can be affected by the atmosphere, the pressure, the humidity. It can be affected by all these things. So that was subrefraction. Super refraction is going to be where we have cold water. So that's, you know, Pacific coast here. We have much colder water than the East Coast. And warm air. So we have cold water and warm air. That radar energy, okay, we'll go back, gets extended, gets, you know, bent with the curvature of the Earth, and we get much longer radar ranges, extended radar ranges. So, so we could possibly pick things up much further out beyond the horizon with the radar when we have this super refraction scenario happening. Ducting is kind of the same thing. I would say ducting and super refraction are similar. You have the cold water and the warm high pressure. Okay, so this is a fancy picture of our vessel, and we get this ducting where our radar energy bends and we get a much further further range. I can't speak. Okay, so we kind of have these three things. We have normal atmospheric conditions, then we have the subrefraction where we get the radar energy going up into the atmosphere, and we get a less range, right? Our range is a lot less with the subrefraction. With the superrefraction, we're getting much more coverage, much more ability to see further with our radar. Okay, so here's our normal, right? From one ship to another. Superrefraction can go much further. Subrefraction, we can miss the vessel altogether. And line of sight, we might not even be seeing the vessel. So here's another picture of that. Okay, any questions on our propagation effects on the radar before I move on? Okay.
None so far.
Okay. We have talked about raycons and SARTs multiple times, but we're going to talk about them again. So our raycon is, what does a raycon stand for? Does it say it here? A radar transponder is what it is. I don't know why I didn't say that. But it's helps you navigate. It helps you identify the blip on the screen as a significant buoy. It's typically your safe water mark. So it helps you identify these aren't boats. You know, this is the buoy that you're looking for. So it will say raycon, and it has a Morse code signifier on it that will let you know which you know, raycon, or yeah, which raycon you're looking at. So on the radar itself, you will see a long, short signal away from you. So I don't like this one, but here's an example. We have a short or a long, short that's moving away from us. So if we are up here and the buoy is back here, it's going to be going away from us. So this, the one that is closest to you is the buoy. And then you have the Morse code signal. And that's what the raycon is. So you have different Morse code signals, but it will say on the chart which signal it is. Now, a thing to note is that you can only see the raycons on a 3 centimeter or X-band radar. So if we have the 10 centimeter or the S-band that we use for, you know, more open ocean, then I was reading your question, Sabrina. An MARP similar to a MARPA.
Oh, sorry, I didn't want to interrupt you, so I just put it in the
That's
chat.
okay, that's okay.
The slide that you were just on, like I think this one was, you were on this one, but then you went to another one that had said like targets and it had MARP. That one, yep, on the left picture, yeah. Is that any relation? Just curious.
Yes.
Oh.
I would say I would click that to get the ARPA information. I don't know what the M would stand for. I want to say this is more of a recreational screen, so maybe, I don't know.
Okay.
But yes. So you could turn ARPA on and off on any of your radars.
Okay.
So
And
that's
ARPA
always a good
is
tool.
a specific software or not a specific? It's just like all the software, like for radar.
So this is my technical knowledge. I'm not exactly sure what a software is.
Okay. Kind of like Microsoft be like.
It's just like, I don't even know. It's like if your radar has ARPA or doesn't have ARPA capabilities.
Okay.
I'm assuming that's kind of like a software input on it, but I am not a technologically advanced person.
Okay.
Call the electrician to help you with that one. I don't know.
Thanks.
Okay. Yeah, so Raycon buoys are on the 3 centimeter, and they are a radar transponder beacon. Radar transponder beacon is what the Raycon is. And it's on the 3 centimeter. Okay. The SART is a search and rescue transponder. SART, search and rescue transponder. They again are on the 3 centimeter or the X-band radar. And what we see on them is a bunch of dots going away from us. So same thing like the Raycon, the blip that is closest to us is where the object is. And then the signal that we get goes away from us. So as we move past it, that line of dots or that Morse code line will be changing bearings as well. But we just get a bunch of dots. So that's kind of like that echo, right? That multiple echo thing that we were talking about. In this case, it's a SART. Okay. We've talked about SARTs and Raycons. Okay, radar maintenance and safety precautions. So basically, you want to be aware of the radar and how powerful this energy is that it is shooting out and receiving back. So you don't want anybody to be near it. So the radar is typically high, so it can see as much as possible. And you don't want people hanging out and sunbathing right next to the radar because you're just getting zapped with, I don't know, electromagnetic energy. So there's kind of these safety precautions. If someone, they call it working aloft, typically is when someone is working up near the radar. Doesn't mean they're working on the radar. Maybe they're painting the mast next to the radar or doing whatever. If they're working aloft and they don't feel comfortable, which they shouldn't, working next to the radar, you want to secure the radar. So you want to turn the radar off enough that shut it down and stop transmitting. So you have this transmit or standby mode on your radar. So you want to stop transmitting so it's not sending out those electromagnetic energy so that someone can work aloft. Now, let me read this real quick. Okay, so AIS. No, the AIS isn't only displayed on your radar screen. So hopefully you have another instrument and the AIS is controlled on its own, and then it's just overlaid on the radar, overlaid on electronic plotter. So it's not only dependent. So things you want to do if someone is working aloft. First off, anyone who is working aloft needs to tell the navigator, hey, I'm going to be working aloft. So not just be like, I'm going to go up there and like, don't care about my body and just like start painting. They want to notify the navigator so the navigator can give you a, like verbally, yes, you can work on the radar, or no, I am in the middle of a traffic situation and I'm really dependent on the radar right now. I can't secure it. So you kind of want to know, get permission. And then it's kind of, I don't know if you guys have talked about lockout tagout. Lockout tagout is a system that's in place on construction sites, vessels, I don't know, power plants. It's kind of a thing that's everywhere. It's essentially that if you are, working on something that it can be energized, you want to secure that energy and not have, even if a shift changes or somebody else comes and they have another project that they need to work on, they don't be like, oh, I think that guy went on a smoke break. Let me switch it on real quick. So it's this very, redundant procedure. Usually there's a binder and special locks where you have this lockout, tagout. You cannot, open this or flip the breaker or anything on something that is locked out and tagged out. So essentially you're doing that to the radar without actually like powering down the radar. You would stop transmitting the radar, put a sign on it and let everybody know and make it definitely part of your turnover that someone is working aloft and that we cannot use the radar. So you just want to make it, communication is everything. I say that all the time. Okay, what did they say? They say state the safety precautions necessary. Okay, state the hazards when working aloft. Describe basic procedures for tagging equipment. So that's your lockout, tagout. Describe basic or scanner maintenance. Oops. Explain why and a maintenance consideration. Radar equipment should be operated a minimum of 1 hour a day. Okay, well, that's not really true for recreational boaters because recreational boaters turn off their radars for extended periods of time. So that's not really relevant. But you do want to maintain your radar. Okay. Our RF radiation hazards. Again, electromagnetic fields are intense enough to cause explosive devices. That's not great. Also spark ignition to volatile combustibles and can be harmful to biological effects in humans. So it's very high energy that we don't want to mess around with. I feel like you could see my attitude on this. I'm not like a super smart person on this, but I know you don't want to mess with it. So that's my takeaway here. Okay, I think we've covered this. Okay, radar and the magnetic compass. So the electromagnetic energy can have effect on our magnetic compass. So we don't want the radar antenna and the magnetic compass to be close to each other. We want them to be a significant distance away. So normally 1 to 5 meters. You don't want it right next to each other. Nowadays, we have duplicates, we have gyro compass, we have satellite compass, but typically we always depend on that magnetic compass because it doesn't need any electricity, right? If we get, green water on the stern and it cuts power to the entire vessel, we don't have a compass, but we still have our magnetic compass. That's why we always want to know deviation and variation. Okay, maintenance, you want to keep the radar clean. That's the actual unit inside and the unit outside. So you want to, make sure you have clean air filters, the trackball, the screen, everything is clean and not, have your pizza on it or something. On the outside one, you don't want that salt buildup, the soot buildup. You want to have the energy being able to move off the antenna. So you want to keep that clean as well. Replace the magnetron per manufacturer's instructions. Yep. Update the software. Sounds reasonable. Self-test. I've never done a self-test on a radar, but I guess your operator manual would tell you if it is. And keep it cool and dry inside. That goes to all wheelhouse equipment. And that is typically why most wheelhouses have their own like small portable AC unit or something that if you are operating in an incredibly hot and humid area, you want to keep your electronic equipment cool and dry. That moisture kills electronics. So yeah, that's that. Okay, any big questions so far? We doing okay? Yeah, Sabrina?
This is just something like little, because you were talking about electric magnetic waves, like if someone is near a loft, like working a loft or near a loft.
Yeah.
So it's electromagnetic and there is a bit of radiation. I think you kind of skipped over that slide, but I saw it like pop up. Is it mostly radiation or?
What were we looking at? This guy?
Yeah, those, the next two, I think you can, the next one? Yeah, I mean, sorry, next meaning like not earlier on, later on. Yeah. So there is radiation.
Yes.
That's all. I was just.
I think so. Okay. Okay. Okay, so now I'm going to talk a little bit about our finals for next week. So they will be available tomorrow on Canvas. But again, with the final exams, no notes or outside materials. We will check in to class tomorrow at 6 o'clock, just like we do every week. And then you can take them in any order you want. We have the radar theory. That's going to be our 30 questions, multiple choice. That is your Coast Guard question format. That's going to be 20% of your final grade. Then you have the single target paper plot, 20% of the final grade, and then multiple target plot, 20% of your final grade. So let's look at those. For our theory questions, there are 4 study guides as like fill in the blank study guides with answers on Canvas. And then there's also a practice test. So the practice test, you can see examples of Coast Guard questions in their weird wording format. And then I would suggest reviewing the PowerPoints or whatever notes you've taken for the theory-based things. So that is going to be what's covered on our theory test. Yeah, it's almost 9 o'clock already, so I'm not going to go over. I'm not going to review I'm not going to review any of the theory stuff. I'd rather do some paper plotting with you guys. But take a look at those theory tests. I'm going to show you right now. So under PowerPoints, week 7 review, we have our week 7 study guide. Here we have our theory 1 through 4. These are our fill in the blanks. So check out those, even if you're just looking at the answer ones. You have the questions and the answers. Just a quick review of all of those theory topics that we've talked about. And then you have the practice test for theory. That's your multiple choice question. So use these study guides. Okay. Back to.
How many questions will be, or like plots will there be on single and multiple?
Here we go. Here is our single target. Again, 20% of the grade. And this is your format. You'll have, you know, your basic information, your own ship's heading course, target, bearing this, range and speed, 6 minutes later, bearing this, or range and bearing and, I can't talk, bearing and range. Then you'll have your questions, which will be in the same format as your practice quizzes. So we have, what is CPA, TCPA, targets true course, targets true speed. Are you the stand on or give way? The standing orders indicate that you have an MX of something and a CPA of something. So those MX and CPA you need to look at on the test itself. It's going to be given to you, right? So don't assume that it's 4 and 2. That's because that's what it says right here. It could be 6. It could be 5. It could, whatever. And then what are your options? So if you are the giveaway, what are your options? If you were to change course, what course would it be? If you were to maintain your same speed, if you don't want to change course, but you want to change the speed, what would your speed be? So same kind of format that we've been working with, hopefully. Hopefully you guys have been working on this. So that's the single target. Multiple target, same kind of format. We have our, what is the CPA of each target? What is the TCPA of each target? What's targets A, true course and speed, targets B, true course and speed. So that's kind of the same of what we've been doing on single targets, but this time we have 2 targets. So then we decide which one is most dangerous. And we have our MX and CPA. So if we change course for our most dangerous target, how will that affect the least dangerous target? What will be the new CPA on the least dangerous target? So that is what you're looking for on the multiple target paper plot. Again, these are practice questions, which we are going to do right now. We're going to do some of the practice tests, same format.
I'm just gonna grab some more tea really quick, but I'm here.
Any questions before we dive into review? Does everyone know what to expect next week? I'm not trying to, trick anyone. Okay. Oops. Okay. Let's get to reviewing. Okay. Scoot over here for a minute. Okay, so I'm gonna start with one single plot. And then we'll go to our multiple targets because I feel like we need a little work on multiple targets. Okay, so I am looking at on your study guides or under study guides, you have practice exams for single targets, and this is your format. Again, I filled it out already, but anyways, we have our own ship's course and speed of 030 at 23 knots. We have an MX of 5 and a CPA of 2. And then we have our target 1020 with a bearing and a range, and 1026 with a bearing and a range. So I will leave this up for a minute so you guys can copy it down if you want to do it with me. There we go. Sorry, I'm trying to.
There a
This thing keeps falling.
Oh, is there a new CPA and MX too?
Yes.
We just
MX 5 CPA 2.
okay.
Okay. So start plotting it once you write it down. Okay, so I have plotted the information they gave me, my own ship. Let me write that. My own ship was 030 at 23 knots, and then I had a blip at 1020, and then I had another blip at 1026, 6 minutes later. So my first step is to connect R and M and get my relative motion line. So I have my relative motion line. And that is going to help me find my CPA and TCPA, numbers 1 and 2. So for CPA, I want to know where that's going to be so I can figure out what time it's going to be. I use my triangle to get a right angle to the center. And I get a CPA. CPA is in nautical miles. So I got 0.9. What did you guys get?
0.7.
Okay. All right. So now we're going to work on TCPA. We know our relative distance traveled in 6 minutes, which would kind of be speed. And we could transfer that to 6 minutes. So let's do that. 26, 32, 38, 4. What did you guys get for TCPA?
1040.
1040. I was going to call it 1041.
You're okay. Yeah,
1040 sounds good.
I'll do 1041 because that does look a little bit.
I'm just saying right in the middle. Okay. So that is our questions 1 and 2, right? What is CPA and what is TCPA? Then we have what is the target's true course and the target's true speed. So in order to find target's true speed, that's going to be our E to M. This was our R to M. We need to plot the E. So we need to plot E using our own information. So that is our own heading, our own ship data was 030 at 23 knots. So we're going to plot that vector to R, and then we'll have our E. So go ahead and start that. Okay, so I've plotted E here using E to R is 0, 3, 0, and my distance there is 2.3. Make sure it's 2.3 because in 6 minutes at 23, it's like, that doesn't look like 2.3. I did that wrong. I did 2.8. Wrong third tick. Always good to double check, right? That looks more like 2.3. Yeah, 2.3. So now I have my E, and I want to plot E. It's already plotted. I just need to read it. E to M to get my target's course and speed. So that's the direction and the length of E to M. Okay, so what course did you guys get?
301.
Okay, I got 304. First time I did it, I got 303.
My I used your nail file thing that you're telling me on my pencil. So, but it's still kind of fat. So I'll have to like sharpen it for sure for the exam.
Did you try doing just
Oh.
using 2 points?
Not right now because I wanted to try it out with the pencil, but maybe I will do that.
Yeah, I think you'll have more accuracy using
I do have a nail file here.
dividers instead, and you can get used to it, right? So you just mark, this one was 23 or 2.3. So you find your 2.3, and then you just mark it where that pointer is.
Okay.
So you don't have to have that pencil.
I see.
It's a little bit of a shortcut that I like to use, but some people don't even have a lead tip that they only use dividers. So
Well,
yeah,
you add to that. Now that my pencil, because it was broken, it's shorter than the needle, if that makes sense. So when you're, I don't know.
Yeah.
Oh, it makes, that was the beginning of radar for myself.
So Joseph, did you get a new pencil or are you using 2 pointy ends?
I did get a new pencil.
Okay.
Although for right now, I'm actually just visually following along. I'm actually out of the radar plotting sheet, so I need to get more tomorrow because I have class at the boathouse.
Cool. Gotcha. Okay. So now we got our course. What'd you get for speed, Sabrina?
I got 23 knots. I don't know if that's like, because our own ship is going.
I got, yeah.
Okay.
22 and a half.
I'm like, is that a trick question since it's similar to our own ships?
No. I got 22, but 23, yeah. Okay. Lost my other book. There it is. So our other target here is going E to M. So they are going this way, and we are going this way. They are on our starboard side, right? Our from our bow to 22.5 degrees abaft our beam, they are in this sector, meaning they are going to be stand on. So we are give way. So the question says, are you the stand on or give way? So we are the give way vessel. So we need to do something to get our MX of 5 nautical miles and a CPA of 2 nautical miles. So we want to bend their relative motion line to give us a CPA of 2 nautical miles. So we're going to find that 5. So I'm going to do only pointers like you. There's our 5 miles. So we'll call it right here. Our MX. And then we want to make the CPA. So if we bend it this way, they would be going behind us and we would be going in front of them. We are the giveaway vessel, so we do not want to go in front of them. We want them to go in front of us. We always want our new relative motion line to cross our heading flasher, to cross our bow. So we're going to bend that new relative motion line from our MX 2 nautical miles towards the front of us, so that that vessel can pass in front of us, because we have to give way to them. They could just maintain course and speed, and we're not diving across their bow. Okay, so we have our new relative motion line. So Joseph, what's next? I know you're not doing it with us, but what's our next step?
You just plotted your new relative motion line. Targets, okay. You already did that.
Yep, we just, from MX, we created our new relative motion line. Now what do we do?
You need to find your R prime to find the new course.
Yes. So we need to move our new relative motion line from MX to M and draw the opposite way. So there it is from MX. Parallel it up to M. And this is our new relative motion line. All right. So now, I'm going to do only pointers here. Our speed, if we want to maintain our speed, right? So question 6 is, what is your new course if you maintain speed? So our speed was 23 knots. I can double check to make sure that's 23. Yep. There is 23. And where does that 23 cross my new relative motion line? So right there. Is going to be my R prime. So now I have E to R prime. Is going to be the new course or new speed. So I'm going to measure my E to R prime and see what it would be. And I have, what is yours new course, Sabrina?
Give me 5 seconds. I'm changing out to the new.
Okay.
Sorry. I have it there. I have E to R prime. I just need to measure it because when I had the pencil, it was too short, and then I feel like that would be off.
Yeah.
It's definitely going to be more than 23 knots, I feel. That's a hunch.
Wait, what? We're maintaining 23 knots. What's your new course if we keep 23 knots?
Oh, I'm sorry. We're doing sorry. You asked what is our new course?
Yes.
Hold on. Let me look at my notes. Please hold. A word from our sponsors. Can I phone a friend? Is the
Yep. So
is
you're
the-
looking for E to R prime.
But when you roll it back to the center,
Uh-huh.
is it still E to R prime? Like that's where you
Sure.
find the 3? Okay, then it is. It is 096.
Yep. I got 0.95.
Okay.
Okay, you're the one that's doing it with me. What is your speed?
Okay, now I'm going to measure the speed. Okay, let me write that down. 096. New course. What is it called? Just
E to R prime?
no. What do you write? CSE, but like, do you write new course?
Yeah,
Sure.
I just put new CSE.
Okay, and new speed.
So our new speed is going to be if we maintain our course. So our E to R direction is the same, but our speed is different.
Is it
If
20?
we slow down. So where does this vector connect with our new relative motion line?
Mhm.
Right here,
Oh,
kind of the center of the kite, if you will.
yes, the kite. That'll be really short. I'm sorry. I think I'm going too fast because I'm trying to keep up with you.
It's okay, I'm trying to.
5 nautical miles.
Yep. I called it 5.5, but sounds good. Okay. And that is all we do for a single plot. So we did R to M was CPA and TCPA. Then we had to plot E, and we did E to M for what is the target's true course and speed. We see if we're stand on and give way. And then both of these are going to be E to R prime. And I'm going to put a little star there. We are creating R prime for course and R prime for speed. So we are creating 2 different R primes for this answer, for those 2 answers.
Because you're creating 2 R primes because one R prime is with the arc and the other R prime is from the E to R line.
Correct. So we had an R prime here and an R prime there. Okay, any questions on our single plot?
So I did that on a regular like 8x10 sheet. Like these are the sheets that I printed out. Because remember I was telling you I ran out of the bigger ones.
Mhm.
And I'm pretty spot on to you. Do you see any like thing that would hinder me from using these, you know, going forward till the end of the class?
I would suggest using a radar plotting sheet for the final,
Okay.
just because the 8x10 one is smaller.
Mhm.
So, just like when we have a triangle that's really small,
Mhm.
you can get, you know, off very easily. Just a little touch of the dividers one way or another can put you off 10, 20 degrees, even though, you know, you plotted it right. So I think the bigger it is, the more accurate your plotting is, especially for new plotters.
Mhm.
So you don't get that poor plotting or sloppy plotting.
Totally. Okay. Yeah. Again, I think I had told you on Saturday, I had asked, I think it was Terry when I ordered or I got the sheets, and she was like, oh, you won't need that much. Like, she's like, I'll just give you 6. So I wanted to order or buy a bunch of them, but she kind of was like, oh, you won't need that much. And I was like, okay, but
the more you practice, the better it will be. I like to say the more you practice, the better. Of course, you don't need it, but yeah, seriously, practicing helps. Yeah, so I think practicing on the small ones is fine, but I would say just, I guess me personally, for the final, I would want that, you know, extra wiggle room for accuracy. Yeah, long answer on that one. Okay. Do you guys want to do another single or move to a multiple?
can we move to multiple? But that's just my vote.
Okay. You're the one doing it with me.
Multiple's good.
Okay, I did want to note on the second one of the single plots, we are the stand-on vessel, so we technically don't have to give way if both vessels are power-driven vessels, because they are on our port side. So don't freak out when you get that answer, is what I'm trying to say.
But would you find a new course and speed?
So I did do the find new course and speed, and you end up turning left. So this is kind of a situation of maybe they're, you know, restricting their ability to maneuver. Maybe it's a survey vessel towing lines or something. It did end up turning left to get a course change so that they cross ahead of me and I don't turn right to cross in front of them, because I kind of flipped it to say, okay, what if I was give way? I'd want them to pass in front of me. So I guess I would say the second page of this is weird. You might get some weird answers, but don't be freaked out by it. You might even just want to skip it and do the next one, or focus on the multiple plot ones.
Where did you say these are? This is study guide or this is homework?
Study guides.
Okay.
So yeah, so study guides, you have, oops. You have the 3 practice tests. So you have practice test single, practice test multiple, and then practice test theory. And then you have like study guides for the theories. But yeah, these are your practice tests. Okay. So yeah, that's my caveat when you're doing those. I guess I didn't put up the answers to these. I will do that. I will do the answers. I will put up the answers to him. Put that on my list. Okay. Okay, so now I'm going to go into practice test multi-target. So let me zoom in here for you. Louise, are you practicing these along with us too? He's not there. Okay. Did you write it down, Sabrina? Okay.
Yes. And can I make a note about target B, or should I not like make a note?
What do you mean? You should write it down.
That since the bearing stayed the same, doesn't that mean we're on collision course?
That does.
Okay. I didn't know if like, no, don't say that yet.
Yes. Oh, that's a good good brain flow on that. Okay. This is okay. Okay, so I've plotted my R and M's for 12 and 1206, 12 and 1206. And I've connected the R to M to get my relative motion line. So on my relative motion line is where I find my first two things, which is CPA and TCPA. So Sabrina, you are right. My CPA for target B is 0, but I still need to find my TCPA. For target A, I need to find where that CPA is and then the TCPA. So I'll get my triangle. That is my CPA. I'll get my distance. CPA is in distance. .8, 5.9. I'll call it 5.8 nautical miles. TCPA. Again, I need to do this for both. So there's 6 minutes. And another 6 minutes. So that's 12, 18. We have 12, 18, 24. How you doing on it, Sabrina?
I'm a little behind because I first put target A's R at 155. I think because it's on the bottom of the plot. Like I got confused.
Yep.
My CPA was a lot closer, and I'm like, this is wrong. And then I,
There you go. You can figure it out. That's good.
I'm catching up.
Okay. Okay, so while Sabrina's catching up, Joseph, what are we going to do next?
Let's see, you found both relative motion lines. You found the TCPA.
Yep, we have.
Next, wouldn't you? Oh, there we go. Target say true course, true speed, but to find that, we need to find E, right?
Yep.
So we should find E for target A first.
Yep. So we need to plot E on both. And we try to do it at the same time, so it's efficient. So we get our course, and oh, you roll it off the page. 1, 2, 5. Okay, roll it down to this R, then roll it down to the next R. So I just plotted the line 1, 2, 5 on both R's. And then I'll get my 20 knots, which is 2 miles. And I'll plot that on both lines that I just drew. And that is my E. So now we have our E in our triangle. And to get target's true course and true speed, we plot E to M. So let's see where I'm going to write this. E to M is target course and speed. So I will connect those. So we have E to M. And we drag it to the middle. Mine doesn't go far enough, so I'm gonna extend it. And I get a true course of 0.45. E to M on this guy. I get a true course of 0.62. Oh, I didn't draw the line. So I have my E to M direction, and then I need to get speed. So A is going real fast. How fast? 3.8. So a speed of 38 knots. Whoa. And target B is going pretty fast too. .32 knots. I got some fast moving targets out there. Where are you at, Sabrina?
Sorry, I'm almost there. I just did my targets true course, but I'm trying to do speed.
Yep.
I'm like listening to you guys, but I don't want to listen to what your answers are. What did you guys get courses? Or yeah, 045 and 062. I
Yeah.
got 048 and 062.
Okay, cool.
Okay, and then speed, I think is just measuring E to M, but yeah. E to M. 33? Oh, 32. For B, sorry, I did B first.
33, 32. That's fine.
And ooh, like 37?
Yeah, they're going fast.
Oh yeah, you did say that. I heard you say, oh, they're going fast. Okay, now I'm caught up.
Cool. Okay, so we did CPA and TCPA of both. Then we did targets A and B's true courses and speed. Then we have which target is the most dangerous target?
Both of them.
We would say B is our most dangerous target.
But they're
A's
both
got a big CPA. They're crossing in front of us, but they got a big CPA. Target
Okay.
B has a 0 CPA.
Mhm.
And we are the giveaway. Right? Maybe this guy's a jet ski. Do jet skis go like 40 miles an hour? I don't know.
I don't think so. Maybe.
I don't know. It's a fast ferry. So we are going to maneuver for this guy and then see how it affects this guy. So B is our dangerous target because of our CPA. Okay.
And we are giveaway.
We are giveaway. So we are going to use MX of 5, CPA of 2. And we're going to use that for B. So I'm going to find 5 nautical miles. So now we're just focusing on target B. So there's my 5 nautical mile MX. And then I want that CPA, that new relative motion line, to pass in front of us. So I'm going to move it on this side. All right, Sabrina, so what do we do next?
Then you'll need to, that's the new relative motion. Oh, you already wrote that. Transfer the new relative motion line from MX to the target's triangle to M.
To M, yep.
Target B in this case.
Yep.
And then we will make a new line from M away. What is that line called? I'm sorry.
New relative motion line?
Yeah, that's just an extension of the new relative motion line.
Yes. Zoom in a little bit here.
Create E to R prime line. Oh, it's going to be hard to do the arc when I have just little.
That's okay. I'm just doing pointers.
Okay.
Okay. So yeah, we have our new relative motion line. So our first, well, our only one on this one is if we maintain speed, which was 20 knots. Let's make sure I have 20 knots. Oops. There's 20. Okay. I want to know from E, where does my 20, my 2 miles, touch my new relative motion line? So I don't have to swing that arc.
Oh.
I'm just going to mark it with my pencil.
Oh, so you didn't do the arc, you just put a little dot on the new relative motion line?
Yep, I just saw what I used my 2 miles because I'm going 20 knots.
Okay.
And I went from E to where does it touch the new relative motion line, put a dot.
Perfect. R prime and then E to R prime.
Mm-hmm.
And then you'll roll back to the center.
Yep, which isn't too far.
And measurement degrees. So it's gonna is the degree gonna be like E to R, or if we had, are we turning to
Yep.
starboard?
E to R, we're turning to starboard. So this is us and we're turning to starboard.
Oh, that's right. Okay. Hmm. 208.
All right.
6. New course. 208. And then we'll.
Well, how about Joseph? What do we do now? We got our new course. Like 206, 208, something like that. How do we get CPA to least dangerous target?
To get the CPA of the least dangerous target. That's for new course on CPA. I am spacing out.
We fix it out. That's okay. So we've created a new course, our E to R prime,
Right.
for target B. Now we need to transfer our E to R prime to target A to see what our new R prime to M is going to be. So we're looking for R prime to M. So we need to plot that R prime on the least dangerous target. So we're going to use
Okay.
E to R prime. Move it over. And we need the length, which was 2. So now we have R prime. Our E to R prime. We just transferred that one over. Okay,
Alright.
now we need to, so now if I connect M to R prime, that is our new relative motion line for target A. But I need to know where I'm going to put it along the old relative motion line. And how I do that is by time of when is my MX, when am I going to make this turn? So here, I'm going to make it in between 1206 and 1212. Maybe call that 1210. So where is 1210 along this guy? Call that half. Call this 1210, because 1210 here. So I'm going to call this my MX. So when I make that maneuver, this guy is going to be right here, and this guy is going to be right there. Now I could transfer my new relative motion line that I've created on the triangle, R prime to MX, to get what my CPA will be. There's my new relative motion line to MX. Of course, it's going to be over all the stuff that I wrote. But this is my new relative motion line for that target. To get CPA, we do the same thing, a perpendicular line to the new relative motion line. Which is going to be really close to our point of execution. And we get a new CPA. So I could see us being confused by our heading line. We're looking at our CPA line here of, I got 6.4. So R prime to L gives us a new CPA of, what did I say, 6.4 nautical miles.
I got the same too.
Okay. Did that make sense, Joseph? Kind of remembering?
Yeah.
Okay. Okay. So that was our multi-target. So we are not going to have time to do a whole nother one. But again, all of your practice exams here are the same format. So practice, practice, practice. I'll put the answers up. But again, feel free to email me. Let me know when you're studying or you're doing your practice exams, and I could do them with you guys. So feel free. I am self-isolating at home, so I have all the time in the world. that's all I got. Next week, we'll check in and I'll answer whatever questions you guys have, and then we will start the finals. So we have 4 hours and we have 3 finals to take. So it will be busy. Yeah. Any questions? Well, have a good week and good luck on your other finals.